just waiting for things to go live here on YouTube. Alrighty, looks like we're live. Alright, welcome everyone to another stream on building a ROS2 robot for SLAM. So, we're going to try to make sure the cats don't eat my wires. That's what we're going to do. Alright, either way, we'll have to keep an eye on those little ones. They're feisty. They like to eat. Very cute and very cuddly, but they also like to nibble on wires because they're teething. Sorry. All right. Anyway. All right. So today, actually, let's recap where we left off. So in the last stream, I believe we started taking a look at ROS2, and we were going through basically we went through a couple of the basic command line tutorials. And I believe we left off on this writing a simple publisher and subscriber tutorial. But what we're going to do today is to try to make things a little more interesting. We're going to skip, not skip, but we're gonna kind of stop going through these tutorials here. But we're going to try to start getting into what's called we're going to start getting into writing some software to run on our PyPico to start communicating things to ROS. So rather than just doing a simple publisher, we're going to actually start trying to pull some real data into it, right? So, all right. So the first thing, okay, hold on. The cat's trying to eat my wires. Hey, you. Why are you trying to eat wires? Why are you trying to eat wires, huh? I'm not. Don't eat wires. Those are expensive. All right. Got one cat sitting under the desk. And it's like, she already destroyed my USB switch controller. So, I already have to see. Mischievous little creatures. But anyway, so where was I? Right. So what we're going to try to do now is start writing some code to deploy to our PyPico. And what that'll do, we're going to try to start taking some of this code that we've been writing for like the sample test PyBot code, if you remember from the previous streams, and start wrapping it in what's called micro-ROS. And micro-ROS is a project that tries to bring some of the ROS2 ecosystem compatibility to microcontroller programming. Realistically, we don't really want to, I've never used it before, so I don't know what the performance overhead is. My my robotics meetup that I go to, they were saying that it's a very heavy tool. You can easily get away with just okay. Stop it, kitten! Don't eat my wires. Okay, it is a very heavy tool to use, where you could easily just write your own write your own code on your controller, and write your own what am I trying to say here? Wrapping back to even be more simple than that. Basically, the whole thing is that there's going to be code running on a microcontroller that's controlling the motors, reading the LiDAR, reading the motor encoders, things like that. Realistically, all we have it doing is got the IMU, we've got the motors, and we've got the LiDAR. That's realistically the only big things that we've got on the chassis controller. And we need a way of getting that data into ROS. And the most straightforward, probably an easy way would be, we'll just write our own code. We could just write our own code, copy that data over the virtual USB virtual USB serial connection, CDC ACM connection, and then write our own program that would publish a set of topics from an application, and then would that would how we would get the data into ROS. Another thing, the other thing that I wanted to do, again, I said micro-ROS. So micro-ROS attempts to let you interact with the ROS ecosystem directly from the microcontroller. So it lets you use the ROS the ROS messages and things from your microcontroller code, and it implements the bridge to bring those into your ROS tools, your ROS environment for you. All you have to do is kind of write your node, deploy it on the microcontroller, and it handles bridging the data. So we're going to try to take a look at that. And as I was saying, my ROS discussion group that I go to pretty much said they all wrote their own just bridge software to copy from the microcontrollers because it said micro-ROS is pretty heavy, and that may be the case. But I did at least want to check it out because I've never checked it out before, and other projects are based on it. So without further ado, let's start looking at micro-ROS. So I did, I'll admit, I did take a bit of a, what do you call it? A bit of a look at this micro-ROS tooling before. And if we actually go and look at running, we like FreeRTOS because the PyPico has good FreeRTOS support. But one of the things that you'll notice if you start going through this guide, oh dear, fine. If you start going through this guide is that it doesn't actually, they don't, in their default tooling, they don't actually have support for the PyPico. They do have a test repository that you can use for the PyPico, but they don't actually, it's not in their micro-ROS setup workspace management tool and such, doesn't actually have a version for the Pico. So we actually have to do this a little more manually. So we're going to disregard basically this entire freaking, what do you call this? Micro-ROS setup. Micro-ROS setup build agent. Well, we may have to do something about the agent, but anywho, we are going to start by actually going to the micro-ROS GitHub repository, micro-ROS, and they have a version, well, not a version, they have this micro-ROS Raspberry Pi Pico SDK repository. So we're gonna clone this here. And clone micro-ROS, make dir build, cmake ... Yeah. So Pico SDK. Yeah, and we don't actually need ROS tooling in order to actually interact with this micro-ROS because basically they've included a pre-compiled micro-ROS library that we can link to in here, and that actually includes all of these messages, a lot of the messages by default. We probably will have to like censor messages, that's service messages. If we do any sort of like custom services, which we will, like I guess laser hopefully is in here. Message, hopefully laser scan exists in here, right? Laser scan. Yeah, they do have the laser scan in here. Okay. Wow, I'm really off my thing. Okay, either way, so we're gonna clone this, and we're gonna use the Jazzy version, and we will see what happens. So we're gonna go to sources, or actually, sorry, projects. Make a new folder for PyBot. And then we're going to, well, we'll make a directory for our ROS2 workspace because we will need one here eventually. We're going to do git clone https github.com micro-ROS Raspberry Pi Pico SDK. While it's coming down, basically we're also going to need to get the Pico SDK to compile this with. Pico SDK. All right, that is just Raspberry Pi. So we can copy that. And we're just going to git clone our Pico SDK. Pico SDK, we'll git check out v2.2. That, how do they name their tags here? 2.2.0, perfect. And we're going to do git submodule update init recursive. For this to come down. Oh yeah, so while that's coming down, taking a look at this, again, they have this net micro-ROS agent killed it. Okay, sorry. Looking, what is this? Looking, I'm really having a time here. Okay, all right. So the way that this library is generated is this micro-ROS static library script, which basically calls into Docker and does a bunch of stuff. So I believe that this will essentially, you call it, git clone. I think they have an example of how to build the precompiled library. Yeah, pull micro-ROS static library builder kilted, Docker run, project, micro-ROS static library builder kilted. Hey, kitten. What are you doing? Oh, you're fine. All right, note folders added to static library, library generation. Extra packages will be added to static library, library generation. The folders added to will be added to. Okay, so that's how we would do our own, add our own package message types to this. All right, so let's try this because I believe this example is probably compiled for the RP 2040 and we have a 2350. So let's at least just start and see what happens. So, so this script by default. Okay. Well, anyway, before we get too deep into this, let's see what did I just see on my phone? Nothing interesting. Okay. So we're gonna look at, anyway, so yeah, back up here, we're going to go to micro-ROS, check out Jazzy, because that's what we're running. Look at Jazzy. And we're gonna see what happens if we do this Docker, if we attempt to, well, actually, before we even try to do that, let's just try to compile the example. Admittedly, I probably have a version of ARM GCC that's newer than the one they specified because I'm, oh yeah, the Gen 2 version 15.2.0. Okay, so we'll see what happens if we try to link against something from 9.3.1. So we'll do export Pico SDK path equals home, projects, PyBot, Pico SDK, ls Pico SDK path, perfect. And then we shall try to make dir build cmake dot dot, perfect. Then we'll just do make. See if it even links. Oh, hey, look at that. All right, we were able to build it, which is good. But again, we would like to do the, we would like to do the RP2350 and not the 2040. So we're going to have to actually build our own version of this, this, what do you call it? Sorry. This, the shared library. So we'll probably we'll get out of this build folder, and what we'll do is we'll just copy all of this instruction here about running how to build the precompiled library, and we'll do oh, hey, the cat's on the thing. Okay, just a second. No, kitten, I do not wish for you to be on my workbench. You're very cute, but you like to eat wires, so no workbench privileges. Thoughts on the Arduino merger? I'm I'm scared. I'm not scared. Well, I'm not scared. I mean, I'm. It makes me worried about the future of Arduino. I mean, won't lie, because Qualcomm. Anybody who's worked in the software field, or at least with any sort of like ARM or mobile type processors, like knows just how absolutely horrible Qualcomm is to anybody that's not small. Like, if you want to buy less than 1,000,000 chips, like they're kind of just dicks to you, and that you won't get any support, you won't get anything, and so a lot of the talk seems to be, are they acquiring Arduino to try to bring in a team that knows how to deal with small groups, or small customers, at a skill set. And I've seen that people are a little hopeful on that. It's like, well, if Qualcomm buys them, Qualcomm leaves them alone. Maybe they'll keep doing their thing, and maybe they'll have access to some Qualcomm parts that the rest of us don't. But anytime Qualcomm has tried that or has done that in the past, they end up swapping out the people in those orgs that are actually know how to deal with small customers with people from inside of Qualcomm, and they have absolutely no idea how to deal with, like, they'll place the management with people who've been at Qualcomm for a long time, and then they'll end up losing it. And so, like, with Arduino being most kind of sort of open, because they're not entirely open source. Like, for instance, the Arduino bootloader is technically not open source. Or actually, I guess the old ATmega one is, but the code running on the USB to serial converter chip, because there are multiple microcontrollers on most Arduinos. So the main application one, sure, and maybe you can get schematics, but Arduino is I don't think I think it. I would not be surprised if this meant the end of Arduino as we know it, because Qualcomm has a horrible. Even when Qualcomm is like, we will admit we don't know how to deal with small customers. Let's acquire a company that does. They try to pull in the skill set. They usually just end up replacing all the people that know how to deal with small customers with ones that don't know how to deal with small customers, and that's just it. And they've done it before. Like, this wouldn't be the first time they did it. So, I think it's probably kind of the death knell of Arduino in the hobby space. Like, how much longer are they going to produce the old AVR-based ones? Probably not very long. How much long? Like, I bet we'll get a bunch of cool Arduino boards that are, like, based on high-performance processors, like, that would typically be Qualcomm chips that we wouldn't be able to even do because we don't have the data sheets, for the chips. But, yeah, we'll have to see. Like, I don't think that it's going to go well, or I don't think that Arduino is going to keep catering to the. I think they're going to fall out of favor with the hobbyist community, because all of the things that made Arduino great are things that everything that made Arduino great is kind of antithetical to Qualcomm's, like, corporate practices. So it'll be fine in the short run, but in the long run, I don't think it's going to be good. And that's kind of I don't have any actionable information other than that, right? So. But back to this. So we need to start our Docker runtime here, because I don't have that started. And then we're gonna pull the micro-ROS static library builder, which I don't even know what's in here. We're gonna have to. I don't know if this will run the script out of the static library generator folder, and see if we can modify that, or if this is just gonna override a bunch of that. We'll have to see what happens, eh? Right. So, as I said before, if anybody joins now, what we're doing is we're trying to rebuild the shared library that is that's the micro-ROS library, because it's the one that it comes with the one that it comes with is for the RP2040, and we have an RP2350 in our robot. So so let's see. So we're gonna run the static library builder and see what happens. Let's see, library generation.sh. Oh, it might actually run the script in the folder that we provide versus bundling the script, which means we can actually edit it for what we need. So if we look at this library generation thing, we could force which SDK we get. We could in build firmware, toolchain.cmake. Oh, cool. Looks like we'll be able to hack this up a little bit. So let's look at toolchain.cmake. And yeah, see, Cortex M0 Plus, there's an M33 in the RP2350. We're going to want to set, yeah, so all of this is not what we want for the 2350. And the funny thing here is that I think I remember seeing a, not a pull request, but that'd be interesting. What was it? Add Wi-Fi transfer. Are these just issues? Oh, look, somebody filed a PR that added Wi-Fi support to this and they just ignored them. Nice. All right. Fun. Well, I think that might tell you the status of this project. Anyway, issues like request for 2350 support, no response. Support for Pico 2. I think somebody just said, "Oh, I did it," and then gave a YouTube link to a video that does not tell you how to do it. And yeah, and then doesn't do anything. Okay, so what is this? Yeah, okay. That's funny. All right, so quote. No, get up. Sorry, my cat's trying to attack my desk again. All right, get down. No, don't eat my wires. Sorry about that. Gotta keep him distracted slightly. I bought a new desk that has like some enclosed cabinets, so I just gotta actually sit down and set up the damn desk. But anyway, all right. Oh no, something broke. rsync project micro-ROS include action messages failed. Oh, that's not great. Great. Find project source, no such file directory. Wait, so I just ran it as they requested out of this folder, and it just didn't work. That's brilliant. No, don't eat the wires. No. All right. Okay, let's see here. Change dir project live micro. No. No eating the wires. I'm gonna get you. Come here. I'm gonna get you. This little gremlin here. She's very cute. She's been very expensive, mostly to property damage, but yes, very cute little goblin here. Okay, you're trying to eat my mouse cable. You're trying to eat my laptop cable. You pull all of the wires out of my breadboards. Yes, they said kittens would bring chaos and destruction to my home, and this one has brought in a lot of laughs too. I mean, they're still adorable. But okay, so that's a brilliant sign that we just pull. You know, we pull the repository, follow their guide, and it just doesn't work. What else is new? Did I miss something? Did I accidentally build it? No, I built the... Oh, wait. Jazzy. I miss something? Did I miss something? Good diff. Docker. You know what? For the magic of, let's just do it again. Oh dear. Permission denied. What? Why? Huh? Oh no, this is horrid. But it is Docker after all. Library generation. Ugh. Run that again. Of course, we're going to have to rerun this operation every time because it's a self-removing Docker container. Okay. Let's see, pull Pico SDK. List of repositories empty. Deprecation. Build a lot of stuff. All right, find project source, no directory. Cloning into dot. I mean, this should have just worked, right? Should, you know. Yeah, firmware build include no such file, can't stat all of this stuff. rsync not doing anything. Oh, lovely. Okay. Let's look at this library generation script here. Let's see what we see. Find project source, name micro-ROS Arduino. Yeah, we could just to see what the heck happens to. Let's this is proving annoying. Okay. Let's try make der micro-ROS workspace, and then we're gonna do our run one of our Docker containers from the other day. Network host, IPC host, OSRF Jazzy with, oh yeah, here. ROS workspace, ROS workspace. All right, cool. Apt install y gcc arm none eabi. Oh, apt update. Right, it's a Docker container. We're gonna try stepping through this script by hand, see what happens. Do some free debugging for them anyway. So let's try, I don't even know if we got to this building geometry stuff. So we already have our ROS distro set up. So if we change directory to micro-ROS workspace, which I guess library generate, hold on. What do the instructions say to do to run that Docker container again? So /project is micro-ROS static library builder. Okay. Source install. We don't have an install folder. All right, so micro-ROS workspace. We're gonna do ROS2 run micro-ROS setup. Oh, I get it. Okay, so that micro-ROS setup repository that I was saying doesn't work. We need to do that. in here, because that has the one of the targets is just build a generic shared library, so we can do that. And hold on, what is ROS? Let me just make sure ROS distro is what I hope it is. Right. Okay, cool. So we'll clone micro-ROS setup. All right, go back to here, library generation, source, or actually we're gonna have to do our git clone https github.com/raspberry pi/pico SDK to /pico SDK /pico SDK git checkout 220 git submodule update init recursive. Let it clone all this stuff again. Realistically, we're just stepping through the script manually to figure out what the heck's actually breaking, right? I'm just going to do a colcon build here to get all of our dependencies right. Once all the stuff clones anyway. And again, we're kind of just going through this just to see if this tool even is worth using. Like, we can always just write our own bridge software to bring any data we want out of our microcontroller into our ROS system. We would just have to write the ROS bridge node ourselves, which would be fine. It'd probably be easier than going through this. But again, I'm trying to use tools that maybe are considered the way you should do things versus doing things myself where I can avoid it. Anyway, all right, so let's go back to this micro-ROS workspace. Maybe we have to do a colcon build. Okay, now there's an install. Yeah, now we can do a source install local setup.bash. All right, now maybe we can do a ROS2 run micro-ROS setup, create firmware workspace.sh generate lib. All right, package resources is deprecated as an API. Deprecated, that's fine. Interesting though. Micro-ROS. Or does it actually compile firmware? Oh, here. Deprecation warning. Okay, all ROS steps. No. There's the other one being a little gremlin. Hey there, you. Yes. Okay, fine. One down. Be down. All right. That one does not like being caught. That one does not. Yeah. Okay. So, all right. So we have our library. Firmware development workspace, I guess. MCU workspace. All right. So if we go to firmware MCU workspace, we do workarounds, just copy TF2 messages. Okay, well, what if we do git clone jazzy https github.com /ROS2 /geometry2. Copy dash R geometry tree 2 slash TF2 messages ROS2 slash TF2 messages. Team Fortress 2. Definitely not Transform 2. Geometry 2. All right. Make dir extra packages. Extra packages. What the hell? Okay. Extra packages. Copy R. ROS workspace. Oh, did I not bridge? Oh no, don't tell me I forgot to bridge the... Okay. Git clone https github.com/micro-ROS/ this repository. Be jazzy 2/project. Or did I? And then I just overwrote a bunch of our stuff. That'd be annoying. Did I do that? No, I just mapped micro-ROS workspace to my master micro-ROS workspace. Okay, that's fine. All right. So we're gonna copy. Oh, oops. I gotta get back to micro-ROS workspace, firmware, MCU workspace, extra packages. Copy -R. Project. Micro-ROS static library, library generation, extra packages. Star to dot. What is an extra packages.repos? Control messages. All right. So VCS import input extra packages.repos. All right. So clone control messages. That's fine. So we go back up to the top. And then this clean the source repository. There is no source in there. All right, that's fine. Oh, we need to go back up. RM, RF, firmware. I'm in firmware. Oh, okay, yeah. RM, RF, firmware build, which there isn't one. So do export Pico SDK path equals Pico SDK. And we'll do ROS2 run, micro-ROS setup, micro-ROS setup, build firmware.sh project, micro-ROS library generation toolchain.cmake, and then project micro-ROS static library generation colcon .meta. I don't know what colcon.meta. Okay, what does colcon.meta look like? Looks like stiff. All right, anyway, we'll let that run and see if this is worth... Oh, this is where things are failing. Okay. Could not find the requested file. Pico SDK preloads toolchains find compiler. Interesting. Okay. That is probably... Ah, that is in the toolchain.cmake. It is blowing up. Unknown cmake command find Pico compiler. Include environment, CMake preloads, toolchains, find compiler. Yeah. Nifty. So cat project. Okay, so this. Okay, so what it looks like is that Pico SDK, CMake preload, toolchains. There is no find compiler. Okay, cool. Maybe it's under utils now. Find compiler. Okay, it's a tool chain. It's a tool. Sorry. I'm clearly using too new of a Pico SDK. This was built on an older version of. This was designed for an older version of the Pico SDK. So actually, let's see what happens if we look at the ROS kilted version of this and see if they updated anything in here. So toolchain.cmake, they did not. So the new version of the SDK probably doesn't work. So what if we were to install Vim or Nano? Let's use Nano. All right, so toolchain.cmake, we'll do Nano. All right, and then it was in util. Find compiler. Oops. Right. Now let's try rerunning this. Or now we're gonna delete that build folder, or firmware build anyway. Firmware build folder, which still doesn't exist. MC workspace. There we go. Maybe. Who knows? Who knows? Hey, look at that! That looks like it's compiling something. Finished. Hey! I like that. It's compiling something now. Look at that. Look at that. Everything had standard error output because it keeps saying Pico triple defaulted to stuff, which probably, if not defined, yeah, look at that, message, defaulted, set from environment. So if we were to say, comment that out, maybe we wouldn't have such log spam, because we don't care that it defaulted to something. What folder did this delete again? Firmware build. Let's run that again and see what happens. Oh yes, look at that. Only a few things actually are. None of that defaulted thing anymore, anyway. But lots of deprecation, which is fine in the grand scheme of things. And I wonder what version of GCC got bundled into here for the ARM version. So this is done again. All right, perfect. So what is ARM non-EABI GCC? What version is it bundling? 13.2.1. Okay, perfect. It's a lot newer than the one that we're... Okay, cool. So we were able to build ourselves. And now we're going to just exit this Docker container because clearly it was just a simple error in the toolchain file. So we're going to look at... we go back to our micro-ROS SDK thing here, and then Vim, micro-ROS, or let's change all this back to owned by me. Just endless, dot, my password. Okay, so we're gonna look at Vim, micro-ROS, static library generation, toolchain. All we have to do is change this to util. And we're just going to comment out this stupid Pico. Well, yeah. All right, so we're going to try... Oops. We're going to just see what happens if we change this to M33. Change this to M33. We're about to change March ARMV. March ARMV. What is the March setting? What March setting to use for Cortex? Should be ARMv8M, right? MCPU. mthumb. And I mean, there's also an FPU in our PyPico, so I don't know what to use. Okay, well, Cortex M33 should be ARMv8M, right? ARMv8M. No, ARMv8. Oh, I don't know. Okay. I think it's ARMv8M is what it's supposed to be. ARMv8M. Is ARMv8M. Okay, cool. Let's see. CPU setting for RP2350. CMake toolchain file. 33. Yeah, anywho. Let's say, yeah, M33, mthumb. We'll just, no standard lib. We'll just change those for now, see if it works. We're also gonna say export or set. I think it's a Pico or Pico SD. Actually, it'll say in the SDK, right? Pico SDK. Just trying to think of the option I have to set to switch it to Pico 2. Oh yeah, Pico platform to Pico platform to RP2350 ARM. I think that's what we say. Pico platform. What options are there? Pico platform. Oh, it's just RP2350. Okay. Set Pico board as Pico 2. Right. Just set it to Pico 2, right? Yeah. All right. Let's see if that does anything interesting. So we'll remove the. Well, right. There's no. Okay. Docker run. See what happens. Oh. Plus X. All right. Clearly the DOS to Unix tool accidentally, or ends up stripping. I use the RISC-V cores to make life harder. Why not? Yeah. Why? Hey, Shigwa. How you doing? How you doing? How you doing? Okay. That's building. Yay. See if anything interesting popped up here. Actually, sorry, it hasn't got to building yet. Missing argument to March. Oh dear. Arm V. E, Arm V. Unknown March target. Arm V8M. Do I really have to say Arm V8M dot base or dot main? What? What? What is that? What does that even mean? Okay. M dot main. Arm V8M dot main. Does the Cortex M33 support main? Alright, looks like main line. Alright, let's do main. Hey, why not? Let's try that. Just change mod again. Run. Alright. Alright, well, let's see what happens. Anyway, well, maybe it'll work this time. I don't like necessarily what it's doing here, but we're running with it. We're running with it. Let's see what happens. Now, I wonder if any of these pull requests fix the Pico thing. Oh, look at that. There's a pull request to fix what we just debugged. Great. And but nobody even bothered looking at it. And how long this has been up there for? Almost a year. So I don't think anybody. I think micro-ROS here might not really give a shit. Oh, I fucked something up. Cortex M33 complains. You know what? I'm gonna do something terrible. I'm gonna ask Claude and see what it thinks. M-Tune? Pico-ROS. Yeah, really. And here's the thing, is that no time that I have ever actually used the Pi Pico did I manually specify C flags. Usually you really don't want to be doing that if you can avoid it. So why are they... Yeah, honestly, I might just fork it and make it not suck. Here, March, M-Tune. Only use MCP. That might as well. Yeah, like, let's delete March here, because we want to use the FPU. We want to use the FPU. Everything... I mean, why... mfloat ABI equals hard. No, kitten, get off the table. Hey, you get off the workbench, eh? Come on. Stop. Oh, damn it, I popped it over again. Stop eating my wires. Stop. You little gremlin, please stop. Please stop eating the wires, okay? Please stop eating the wires, eh? Mm-hmm. Yeah. Mm-hmm. Cutie. Mm-hmm. Snuggle the kitten. The kitten just wants attention, really. Cat break. Alright, so how much of this is needed, really? Hi. Maybe. Cat. Yeah. Alright, I'm gonna put you down. There you go. Okay. Yeah, maybe we don't. I don't know. And float hard, FPU. I don't even know. Can we, maybe if we look in the Pico SDK, there'll be something interesting in there, right? Pico SDK grep March. No. March in Pico SDK. Okay, cool. ARMv 8.0. Not embed, tiny USB, C flags. Okay, Pico common lang flags. mthumb. Oh, dot main plus FP plus DSP. Okay, we could do that. Did I save this? Oops. M2 or M March is ARMv8 m dot main plus DP plus or plus. What did it say? Plus main plus FP plus DSP. Okay. Plus FP plus DSP. Change mod. Not that. Run again. Real question here too, though, is why are we overriding these flags manually, right? Set flags, set C, make flags init. Wouldn't this find compiler thing like set up any things we need? Like, let's go projects, Picobot, PyBot, Pico SDK. What was this? Lib? No. CMake. Preload. Tool chains. Like, yeah. Util. Find compiler. Like, toolchain path. Find compiler. Yeah, I don't see a bunch of conflicts this time. Nice. I don't see a bunch of conflicts this time. That's good. Util. Yeah, Pico lang flags. ARM common system processor. M33, do the thing, common lang flags. Where would common lang flags be applied is a good question. Why would we add soft FP though? I don't know. Whatever. Some files can't be transferred because it's stupid. Well, it finished building. Project, micro-ROS. It's terribly annoying. Okay. Rsync. Am I really gonna have to make me? Am I really gonna make me do this all over again? What is that cat doing? Nope, cat's eating my wires again. All right. No! No! Get down. Being very mischievous. Okay. All this rsync stuff is failing because of course it is, because this couldn't be easy. Update library generation.h. Maybe this will fix something. Who knows? All right. Wow, this really is busted. All right. Fixes this. What are the rsync things? Reconfiguration, branch, downgrading SDK, project. Yeah, well, I mean, all that shit's not building. So it built now, but this rsync stuff is not working. Okay, so what does it do? For var in include ROS2 packages, fix include paths. Well, shoot. So looks like we're gonna have to manually fire up a container again. Docker run. Before I even do that, micro-ROS workspace. Docker run. Oh my god, she's back up there. Okay. The more I take her off of something, the more she wants to get up there. Because I mean, she's a cat, but I don't like to get down. Okay. I don't want you up there, baby. All right. Slash present working directory slash micro-ROS Pico SDK is going to be mounted to slash project. And we're going to do apt update. Apt install the compiler again. We're doing this. Of course, we're doing this again. What the? No! No! All right, I'm going to clone the Pico SDK. No, 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 no. Okay. Pico SDK. Git log. Alright, git log, git submodule update init recursive. crawling under my desk and jump it up with the cables. Ugh. No, don't eat that one. That's the high voltage one. All right. That's, If you get a nick in that, it's probably gonna kill you. That would be very sad. All right. Now we need to bring this as micro-ROS. I already have our micro-ROS setup. Micro ROS workspace ROS. And colcon build. Source install local setup.bash. Project. Alright, and then do, so we do ROS, do that. We'll just copy this as a big block of stuff. Just sit up there again. No. No. I'm gonna have to throw you out. Alright. Alright. Okay. Yeah, I lock one cat out and the other one's like, wait, my sister's outside, I'm confused. Hi. Oh, they're both out there. Okay. I've been locking them out of the office until I can get that new desk set up. But anyway, alright, so we're going to paste this stuff. And alright, cool. Looks like clone control messages, remove stuff. MC workspace. Extra packages, control messages, and ROS2. Transform messages. Okay, cool. Now we can do this. RMRF firmware build, which doesn't exist. We do our build stuff. Clearly it worked down to generate extra files. Well, this rsync stuff failed. All right. Does it actually copy C files into include? No. Copy include star. Micro project. micro-ROS include. Nice. And then copy our firmware. project, lib micro-ROS, lib micro-ROS.a. What if we did a file? On the file command's not installed. File. All right. Well, that didn't help. All right. And then the fix include paths. Firmware, MC workspace. What does colcon list do? All right. Echo include ROS2 packages. All right, I see that. So we //// back up into here, and we'll do apt install rsync or f in or for var in include ROS packages. Do echo var done. Okay, so that's what it shows. All right, so let's see what it's trying to do here. So ls project lib micro-ROS include, let's just say tf2 messages / tf2 messages. Okay, I see that. See what it's doing. Okay. So, I don't see why this rsync would fail. All right, I see. It's saying that there's no such directory. Interesting. ROS IDL, ROS2 trace. Do I see TF2 messages? Trace tools. And watch this rsync thing not actually have theoretically been a failure. If the thing doesn't exist, then let's see, like this project, lib micro-ROS include TF2 messages. Yeah, so that worked. So these rsync that might have just been a red herring, honestly. Let's actually scroll back up to where we saw the rsync fail previously. Rsync error, and then do this extra stuff. Let's see if any of this actually returns stuff. Generate extra files. Yeah, doesn't actually return any output. So we wouldn't have. Oh, okay. So none of these had any files to transfer, so it just reported that it failed because obviously there were no files to transfer. But then after that, all of this other cleanup stuff doesn't actually output anything, so it looks like it just failed with rsync output. Okay, so if we were to say look at project lib micro-ROS include trace tools. Yeah, trace tools trace that doesn't even exist. Trace tools. Yeah. Okay, cool. All right. Stereo messages. Message. Yeah, all right, fun. All right, so it was working. It was working the whole time. We just didn't know because the output here is stupid. Okay. I can live with that. That's just annoying. So we'll delete our build folder here. We'll just, for good frickin' measure, we'll do one last Docker run just to see. Just I love how this took me an hour and a half, I suppose. Yeah. Okay. Oh, and yeah, the fucking bullshit. Okay. There we go. Can everyone see this is a very well-maintained project? Alright, so once this is done, we're going to get a bunch of rsync errors for folders that don't actually have include headers. Or headers to include. And then we will build this with the Pico 2. You know, I wonder. Why would it have used soft float? Let's see. Pico 2 or RP2350. Pico SDK, use FPU. Soft FP, hard FP. Sadly, GCC does not have Okay, so they do. Okay, so we're gonna do this again. We're gonna run Docker again because we actually need to use soft FP mode. Okay, that's cool. That's cool because they've done some funky shit. Okay, fine. Disable, if not, no. Alright, well, anyway, hold on, let's copy this shit over while we are thinking about it. Brilliant. Also, this is disgusting that we have to actually set this up ourselves. I need to come through here and look if there's a way to avoid having to... I need to come through here and look and see if there's a way to... rewrite this toolchain thing to not need to manually specify flags. So we did that, commented that out. Just double check this again. Soft FP, M thumb, March, all that crap. Just what is this MCMSE? What actually is that? Oh, CMSE. There. If not, no CSM. Okay, is that defaulted to on? Pico config. If not, no Pico, double negative. Okay, so if we don't specify Pico no CMSE, then add CMSE. So, okay. Okay, now we'll run Docker one last time. We gotta do the change mod thing though. Alright. Hopefully that's the last time we have to do that. And we'll get our RP2350 version of this Pico SDK thing. Sorry, of RP2350 version of the micro-ROS static library. And so while we're waiting on that to build, I've got a RP2350 here. We'll try to see if I remembered to see if I, well, okay. We'll flash the UF2 whatever onto here with, we'll put it into boot mode. Or the flash drive mode, right? Yeah. Oh, this is building again. Cool, but at least it is building, which is good. Okay. Those aren't going to work because those don't actually have headers. This is fine. All right, and then we're going to look at libmicro-ROS and see that it was built at right now, which is good. So that's a big library. It's a good old 14 megabyte library. Look at that. Okay, so now that we have our thing there, Pico micro-ROS sample, LED pin, do all that shit. Okay, cool. We're going to edit the CMake lists. Pico SDK import, do the micro-ROS thing. Doesn't specify anything about Pico 2 in here, which is good, so we'll do a make dir build. Okay, so go to build, CMake, CMake, build, type, release. Use the Ninja generator because I like Ninja. D Pico platform equals RP2350. D Pico board equals Pico 2. ... Perfect. And it built. Okay, cool. Doesn't mean it's gonna work, but it doesn't mean it's, build.ninja. Let's see here. Flags. Oh, we could have looked in here to see how it outputted shit. Okay, cool. Nice. I like it. Alright, so now what we're going to do is we have Pico tool installed. Pico tool. Which Pico tool? Huh. Who provides that? Oh. I somehow have a Pico tool. I guess Gen 2 somebody packaged Pico tool, isn't it? Okay, cool. So, now we can finally close all that shit. Close this, go back up to top level. Alright, Jazzy. Alright, nice. So we shall do Pico tool list. Oh. Info? No. No command. Program information. Anyway, Pico tool load build. Oh no. All right, and in theory, this is running micro-ROS on our little 2350 board here. Maybe. So, we shall copy this, see if it runs. That'd be nice. All right. Is that running? Client key. Who knows? What is it doing? I don't know what it should. It doesn't say what I should see. Let's look at the example. Transport open, Pico node. Well, now we need to. Okay, hold on. Privileged. IPC equals. Let's. All right. Oh. Oh. It did work. Oh, but now it's definitely not working. Okay, let's reboot the Pico. Oh, okay. Well, let's see. The LED is flashing, right? Something's happening. Timer callback. Spin some. GPIO LED pin. Add timer, init, default, publisher init, connect. Put LED 1 if something works. And it connected. And I got a LED solid on here. Okay, we're running micro-ROS on a 2350. We got that to work. Oh my god. We updated the SD. Took us an hour and a bit, but we got the SDK working. And we got... Okay, well, what can we see? The reason I wanted to do this IPC host is now we can try to run Docker, run this whole thing we were doing earlier. Go to projects, Pico, or PyBot. Do I have a ROS workspace? Or no, tutorial? Was that what I called? Anyway, Docker, run IT, host, where's one of my old ones? ROS2 workspace, ROS2 workspace. Okay, cool. I'm going to try to do run RQT, right, Racket? Or can I just run RQT? Oh, sorry. Xhost plus. I forgot the magic command, right? There we go. Running plugins, topics, topic monitor, right? Eco publisher monitor. Look at that. It's publishing. Oh yeah, look at that. Okay. Let's see. Services. Message browser. Okay. Yeah. Okay, Pico Publisher is publishing. Pico node. Is there a node? Plugins. There's a node graph, right? Pico node. There we go. Okay. Yeah, here we go. Pico node, Pico Publisher. What was that? And the bandwidth runs at 1 hertz, which is exactly what we are expecting, because this is supposed to, this timer is supposed to run, yeah, once per second. Okay. Hell yeah. Look at that. Look at that. We got micro-ROS ready. That was a battle. I'm sorry. Well, I mean, admittedly, it only took an hour and a half. Can it be that much of a battle if it only took an hour and a half? But, okay, I'm going to take a sip of water. Take a little break here, huh? Now, the real question is, how do we support the upstream disconnecting without the Pico crashing? Yeah, that's the oops. No, not. I don't want Claude in here. All right. So anyway, let's get it to run on FreeRTOS now. Let's just take this up a notch here. Presumably... oh yeah, let's close that. Okay. Perfect. Perfect. I love it. Nice. Kill that. So... I'll also exit that. Okay. Pico Publisher... All right, so let's see what it looks like in these micro-ROS, some of this FreeRTOS stuff, right? And another thing too is that we can copy these some of these micro-ROS files into our own repository anyway. Yeah, because this is just simple stuff. Okay, so what we'll do? All right. Wow. Sorry. Processing here. Okay. Well, first thing that we're going to try to do is we're going to set up FreeRTOS in this folder. Try to boot on top of that. Or actually, sorry, before we do that, let's look at this micro-ROS, like, because, what do you call it? Micro-ROS FreeRTOS, because it's supposed to be able to run on FreeRTOS, but, ugh, that's a bunch of useless. FreeRTOS plus here we go. Apps, init32 publisher, which is kind of what we're looking at already. Colcon meta. I wonder what that looks like. What does this meta folder look like? Does Colcon show anything in here? Oh, I bet in the libmicro-ROS archive thingy here there was a Colcon. Yeah, there was a Colcon meta in that static library generator, right? Yeah. Here we go. Here we go. Max nodes, 10 publishers. Look at Colcon meta again. Yeah, max node. Publishers, subscription services, clients history. Okay, yeah, so we would have to change this stuff in order to actually have more of any of those resources. So, okay, but that's fine. So app.c looks like, what do you call it? There's this app main that's getting called, and we're not calling that. There's an executor that's created, spin some micro sleep, run for 100 nanoseconds, or milliseconds to nanosecond. Run for 100 milliseconds, sleep for 100 milliseconds. Right? Micro sleep, so it's 100,000 microseconds to be 100 milliseconds. And then vtask delete. Free resources, but this would never actually exit. Okay, so it looks like... Okay, so there's something in here that's setting up other things. Oh, sorry, we were just there. Maybe the mains are in these extensions? Oh yeah, look at this. Startup code... What's in this? Oh, that's a lot of stuff. Micro-ROS transports. Oh yeah, look at that. HAL receive DMA. Using DMA agents to copy things. Neat. Okay, okay. Okay. Fun. Micro-ROS transports. So that's their transports implementation. What does main do here? Ooh, lots of stuff. Creates OS thread, kernel start, whatever that does. FreeRTOS maybe? No. OS kernel start, maybe that's in here. Init task function. Oh, open the transport. Try to connect, set up the FreeRTOS allocator. Oh, sorry. RCU utils get 0 initialized allocator. Set up, use these FreeRTOS allocators. Interesting. Vport. Oh, so we have to set up allocators to bridge. So that's how it. We have to set up a heap. Or okay, so we have to set up a heap for for RCU utils, and then it runs micro-ROS app xget task handle. Oh, okay. So all it's doing before it's calling the set transport and then setting up an allocator. Okay. Okay, that's fair. So if we want to do micro-ROS example, if we want to look in here, we have allocators, get default allocator, right, okay. Which probably bridges to malloc and stuff, which we don't want to use for FreeRTOS, I guess. Or, I mean, maybe, who knows. Okay, well, let's see what happens. You know what? Let's send it. Alright, so let's just send it. So what we'll do is, what is in this Pico transports? Clock get time US 64, sleep sleep US. You know, I don't like that. I don't like that. Init all. Read, get char timeout, elapsed time. That's another thing too, is I don't know how well, micro-ROS will participate in an RTOS ecosystem. Like, will it? There's nothing to do. Will it yield to the CPU? Anyway, what did get char timeout US do for? And maybe we could use this get char timeout. Just we do a thing that'll deschedule us. That might be fun. Might have to work on how that works a little bit. All right, so let's let's copy our FreeRTOS logic from our PicoBot project. So that'll be in projects arm pi Pico PyBot, right? Dependencies. I'll just copy this dependencies folder over to here. Projects arm Pico PyBot CMake lists. I think all I needed to do was include directory, add subdirectory dependencies. Okay, cool. Yeah. And then, all the configuration stuff. FreeRTOS config. dot. I think that's all I needed because I'm not using LWIP. Yeah, okay, cool. CMake, ooh, hold on. Vim, dependencies, CMake lists. FreeRTOS kernel path, add subdirectory, all this stuff. Vim CMake lists. USB, UART, do a thing in it. Yeah, we'll do an subdirectory dependencies. All right, build. Okay. Oopsie, that didn't work. Dependencies, cannot find file, micro-ROS. Well, that didn't work. That did not work at all. Okay. Let's try not doing that. Oh, wait. Example. Oh, I don't want to build the examples. I2C dev, or... yeah, no, I don't want to build the examples. We'll just do a good old CMake list edit and not include examples. I think I was getting away with that. Oh, there we go, yeah. No, there's the failure. Okay, yeah, Vim, do an include directories, CMake, current list dir. There we go. Okay, cool. Nice, we built stuff. All right, I think I was getting away with that earlier because we were explicitly building the target for the balancer code, and that just, it didn't depend on an example, so it didn't build it. Okay, so now we have FreeRTOS in our project. And so let's start with doing all of this FreeRTOS allocator shit. We do, I don't know if I like the Pico UART transport, but I don't know if open, I mean, require init, true, false, return true. You know, I really don't like the idea of calling that at runtime. So we're just going to return true. And in our main Pico, we're just going to do a good old stdio init all here. There we go. I'll walk that better. And then we're going to do a Pico tool load build. Yeah. Has to reboot. Yeah, because it's using the stdio transport, we can actually still use Pico tool without having to hit the button. So we should be able to run Docker and have that run for us. Oh. That didn't work. Let's reboot. Rebooting. There we go. Cool. We've got our FreeRTOS. I mean, we got our we haven't broken it yet. Now we got to actually do our FreeRTOS, right? Okay. So, so what we'll do here is we have to set our custom transport. That's good. And then now we need to set up the allocator, which is going to be different because we need to do stuff. We'll copy that and we'll do a, oh, oops. Oop. Oh, I hit the wrong set of buttons. There we go. So say allocator. We'll just call this allocator. RCL allocator T. Or we can say FreeRTOS allocator. Why not? We'll just copy this shit, right? We'll just comment that out. Okay. Okay, yeah. And then delete that bit. Yeah, if we fail to set the allocator as break or return one, no. While one spin forever. What is this? I think Pico SDK spin tight loop contents. There we go. Tight loop contents. Yeah, there we go. Yeah. Yeah. Okay, cool. And then we'll come back to our source allocators. We'll just, these are all our stuffy stuff here. Hit the control button on instead. Okay. Okay, 1, 2, 1, 2, 3, 4. Okay, just to make sure we understand what's going on, absolute use memory. So if we do an allocate of size and state, we just absolute use memory plus size, PV port malloc. We just basically reach out to whatever the configured FreeRTOS allocator is. Deallocate the same thing. Use memory is get block size of pointer, free the pointer. Reallocate, yeah. So this is just basically bridging out these allocate calls to the default FreeRTOS functions. So that we should be able to build that. Well, okay, implicit declaration, because we haven't included any FreeRTOS stuff yet. Projects, ARM, Pico PyBot. Look at our main balancer.cpp, because we haven't renamed any of this shit. Okay. So we've copied some of this stuff. Realistically, we just need FreeRTOS.h for now. Yeah, there we go. Yeah, so do that. Ping agent. Yeah. Where do we do a ping agent? Does ping agent happen in here? Nope. Maybe that happens in app main. I don't ever think it actually calls that ping agent thing. It starts with create node. Support init. Okay, well there we go. Support it starts with support init. All right, so we'll just assume that we know what we're doing. We'll cut the. We'll yank that. No, we won't. We'll cut that. We're going to say this is our main. We'll just use the same freaking thing here. Oid arg. Paste that. Getter T, allocator, RCL get default allocator. Then we'll say all this support stuff comes from over here. Comes over here too. So we'll say, honestly, all of this does. All right. Alrighty. Unreachable program. Return ret. Basically say vtask. Oh, and this unreachable agent is going to be a vtask delete null. All right. Null. This is a void. All right. In theory, that should help us. Kick off kernel. It's going to be a... we'll just look at it from the other project here. All right. Main thread, we'll just... and then we got a vtask start scheduler at the very end. So copy that. Go back to micro-ROS example. Kick off kernel. Main thread goes on core 1. We'll just... might as well just... why not? Main task handle. Is test task priority? What was test task priority? I don't even remember. Scheduler was task idle priority +1. Okay. I'm not going to remember that. Idle underscore priority. Okay. +1 U. And then we're gonna... we'll just call this main task. Ah, oops. It's in the wrong spot. Okay, so that's doing its thing. All right, now let's make sure we can build and link. We need just this thing. Standard lib. No sys equals 0. And add compile definitions, add compile definitions. No sys equals 0. Alright. If that does anything for us. Oh, right, we need to add our FreeRTOS include up here. Oh, I didn't build. Implicit declaration of get block size. That's not great. FreeRTOS.h. Alright, I mean that's not okay, hold on. Where does vtask delete come from? Okay, where having a moment. Where did any of this come from? Oh, task.h maybe. Okay, implicit declaration of get block size, port. Null pointer isn't a thing because this is C, not C++. And now we just need to figure out where PV port realloc in dependencies FreeRTOS. Where does that come from? Port macro. That's not ideal. Interesting. Maybe we shouldn't be using, let's see, Pi, Pico, FreeRTOS, malloc, realloc. PV port malloc, PV vport free. You ought to use those things. Ah yes, realloc is not... All the others are fine, but where does get block size come from? And maybe, do we even need to worry about this this anyway? This is just something copied out of, and this is something I just copied out of here. So does used memory even... It doesn't even do anything. Okay. That's fine. Okay. Used memory. We'll just delete all this absolute stuff. Doesn't seem... I mean, we can just ask... Yeah, we can just ask it these questions anyway. FreeRTOS provides some of this, but realloc is the one that's not coming through. I've never... Okay. PV port realloc. Ooh. Ooh, maybe... Is this a brand new part of FreeRTOS? Interesting. Okay, so heap... So there is no... There is no PV port realloc. Oh. Interesting. So why... So how was it doing that? Okay. There is no port realloc provided. Oh, that's annoying. Well, because it doesn't provide a realloc, we might have to implement a realloc ourselves, which would be a return oh dear. Okay. Realistically, we obviously would want a correct reallocate function, but if that's not provided, we have to make a dummy one ourselves, which we can easily do by basically say void pointer new pointer equals PV port malloc size. Well, the problem is we don't know what the original size is either. That's... Oh, shoot. Okay. That's a problem. Okay. AV port realloc. Block link. Let's see here. Okay. If once its size is greater than 0 and PV is not as null, memory being freed, we'll have a block link structure immediately before it. So we can remove that heap validate pointer block. What does it even do? You know what? We're gonna do a VS Code dot and pray here, right? Maybe we can just probably not going to work for me. PV port, yeah. Oh, nice. Now it's scanned. Okay. So realloc, calloc. Okay. So if we were to do You know what? What if we copied this function out of this freaking forum post? Oh, I'm so horrible. Okay. Yuck. That's... Oh, whatever. Whatever. I don't care. I don't care. Just trying to make this work. If heap block allocate... Whatever. I don't care. You know what? I don't care. Ninja. That didn't work. Heap validate block pointer. Oh, this has to be pasted inside of heap 4.c. Okay, well then, we shall take that. No, I don't want to scan for kids. We'll do that. Why not? Why not? Let's just freaking modify FreeRTOS. Okay, dependencies, FreeRTOS kernel. We found this in portable memory manager heap. Portable memmang heap 4.c. If thingy more Malik port free, paste this fucking thing here. Why not? And then we'll find where is any of this defined. FreeRTOS. We'll say oh god, no. Void, pointer, PV, port, re, alloc, ist, void, pointer, hold on, void, pointer, PV, size, t, x, wanted, size, privileged, function, because the other ones say that. Alright, now it happens. I want AI here. Hey, it built. It's probably terrible. Okay. What happens if we run? It probably won't work. We gotta look at our transports here. Pico UART transport.c. So put char, that's fine. It's this get char timeout shit that I don't know about. Get char timeout US Pico SDK here. That's going to be in Pico standard IO get char timeout US. Yeah, probably busy waits. You know what? Send it. Let's see what happens. Ninja build. All right. Let's see the modification here. There was that one modification here where it spins some for 100 nanoseconds and then it sleeps. So let's see about our micro-ROS example here. Main thread, do the thing, task priority, main thread, spin some, and then just busy loop. We're not actually doing any other threads, so that's not necessarily the best test. But timer callback, executor, RCL publish. I wonder what the RCL publish. I wonder what the thread safety of RCL publish is. This timer, it's running on a timer callback, and I don't know if let's see here. FreeRTOS micro-ROS, RCL publish, thread safety. Multiple FreeRTOS task threads can concurrently call RCL publish to send messages without calling unexpected behavior. However, only applies to active publishing messages. It's crucial to avoid calling RCL publish concurrently with other non-thread safe publisher functions, such as RCL publisher fini, which deinitializes the publisher. Okay, well, we'll have to research things, I guess. All right, well, we'll just try this for now. See what happens. We can do Pico tool load. That's doing something. All right. Device has been left accessible without the drive mounted Pico tool reboot. All right. And now if we run Docker, it came up. Hey, we didn't completely destroy it. Okay. So, hold on. So we go to another Docker thing. Docker run stuff. Yes. RQT. Actually, wasn't there a ROS tool that we were looking at that let us RQT console? I don't remember. Was TurtleSim, ROS2, and RQT? Okay, anyway. Running a simple pod. That's where we were. Okay, RQT. We'll do plugins, topics, topic monitor. Look at that. Data. We'll monitor it. 61, 63, or well, it's scrolling. There we go. Well, we'll close that, and we'll do ROS2 topic list. Topic. Echo. Pico publisher. Data 90, 91. Hey, here we go. Cool. Perfect. So we're running on, well, we've got one thread running, so I mean, that's not really a great test, just because again we got one thread running. It's not context switching, so we ought to add another thread to make it do other stuff. Yeah, so off the top of my head, things we need to do. We're gonna need we will now start merging this micro-ROS stuff into the PyPicoBot folder that we have, or PicoPybot folder that we were poking around on earlier. And then I really hate that it's this binary distribution, right? But either way, that's fine, I guess. But anyway, what else we do? Bandwidth or topic bandwidth. 9 bytes from 3 messages, 4 messages, 8 bytes. That's fine. Yeah. So okay. Yeah. So we'll start merging that in. We have to figure out how to deal with disconnects, right? So if we reboot or something, it needs to be able to. Needs to be able to know that it disconnected. And then we also need to figure out if there's any way to make this more RTOS friendly, as in if the executor has nothing to do, it yields the core versus busy waits. I don't know if that's, I mean, hopefully that's doable. I mean, this thing basically would run for 100 nanoseconds and then sleep for 100 nanoseconds, but that means it's not actually doing anything for 100 nanoseconds. So we might just. We do have 2 threads. We do have two cores on the PyPico. So. Interesting. All right. And I guess, yeah, just to make sure, we'll change the name of this publisher, right? Just to make sure that we're actually using the one that we think we are. Pico node. Okay. Okay, that still worked. Okay. And it didn't work because it's FreeRTOS publisher now, right? Yes, there we go. Cool. Perfect. Participant entered. Logger setup. Yeah. Anywho, yeah. Yeah, realistically, I still wonder what the All right, so at any rate, what we should do, what I'm going to do now is let's start. Yeah, so let's start merging this stuff into the our Pico PyBot code base, and yeah, so we'll kill that. We'll kill that folder. Okay, so we can. All right. So we basically just need to take this lib micro-ROS folder. And include lib micro-ROS. Include, oh my gosh. Yeah, TF2 message, sensor messages. Okay. So what we'll, yeah, might as well. So yeah, what we'll do, we'll come over here, we'll do our projects, Pico PyBot, or no, projects are, no, sorry, ARM Pico PyBot. We shall do a VS Code dot. And what we will do is, we got some stuff in here. And what this, yeah, we got a lot of stuff about LiDAR and all that in here. Actually, maybe what we'll do is create a new set of things to do here. Okay. Let me think here for a second. What do I want to do? We want, oh yeah, there was my experimentation with DMA on the LiDAR to get it to actually feed data correctly. Okay. And that actually is another good question. Like, can RCL publish only be called from the same core as well, we'll find out anyway, right? Or, well, maybe we won't. I don't know. Like, the RCL executor needs to run on a thread, but it's not natively, because it's doing this loop thing, it's not natively thread aware. It doesn't, like, split things across multiple threads. So we have to... I wonder if what'll happen if we call one of those RCL publish things from another core. Like, can it handle 2 threads actually running simultaneously? Because I don't know. Like, I don't know if there's a special, like if there's defines or something to micro-ROS to get it to work with FreeRTOS or something. But anyway, huh. Well, it would be cool. It would be cool if we took, I mean, come on. It would be cool if by the end of the evening we could publish laser scans. So we might as well try to do that. And I will admit I did some LiDAR code off camera because I was really annoyed on the other stream about losing packets, which turns out to be just the fact that the latency of spinning up a FreeRTOS or of awaking a FreeRTOS thread, somehow I was losing. There was enough delay that somehow there was an. Oh, that's not great. Okay, somehow there was enough delay that I was actually overrunning the UART buffer. So hopefully we don't do that. So all right, we'll start copying stuff over to a new project here. Oh wow! I just showed my freaking Wi-Fi credentials on stream. Look at that. Okay. And let's see here. Great. I just did that, didn't I? Okay. Yeah, so let's start a new project here. All right, so we'll close that. We're going to come back into our PyBot. We're going to make a. What do we even do? Projects. No. ARM. Pico PyBot. We're going to make a folder, Pico, PyBot, PyBot, micro-ROS, Pico PyBot firmware. Let's just call it Pico PyBot firmware. Pico PyBot firmware. We're going to copy .. Pico balance, or no, Pico PyBot. Oh, well, anyway, git init dot. Bring up another folder just to look at the files we need to copy over. Projects, ARM, Pico, PyBot, git submodule list, status. Yeah, there we go. Okay, so we're gonna make a dependencies folder. Dependencies, git. Actually, cat git submodules. Git modules. Yeah, okay. So we're going to do a git submodule add FreeRTOS kernel. This is not coming down very fast. Git submodule add. CDMA. Okay, cool. And then we'll copy Pico PyBot. OSTK import. Pico pybot. Dependency cmake dot copy pico pybot. Just copying over all the files that we need. Source. I don't know why I did that. Balancer will remove. FreeRTOS or LWIP we can remove. Leave motors. Remove packets. Remove quadrature, and we'll leave utils here. Some utils. Normalize heading, scope block. Yeah, we probably want to keep some of that. Okay. Let's make lists. Oh. Alright, cool. Now we're just using a Pico 2. Actually, we will be using a there is a Pico 2W in there right now. So we'll leave Pico 2W. We will delete all this Wi-Fi stuff, though. Pico pybot firmware. That's fine. Okay. All right. We probably should set Pico platform as RP2350. Cache string CPU type. All right, that's fine. Got that. Include stuff. Projects. That's fine. We can remove MDNS, CY43 stuff. Remove that. We'll just comment this out. We're gonna need PIO stuff in the future, but let's call that main. We got pybot firmware. Firmware, pybot, firmware. Firmware, pybot, firmware. Pybot, firmware. All right. And that looks good. Okay, ITC devlib, FreeRTOS. Oh yeah, main motors, that's fine. Okay, source. Alright, so, iBot, source, balancer. We'll just cut out anything we don't need to source / main.cpp. Now we can do our good old VS Code dot. And this is actually going to be a PyPico project, actually. A close folder. We're going to do a Pico SDK import. We're going to change this to a projects ARM PyBot firmware select. Use the current SDK. We're going to enable that integration. Show advanced. That's fine. Import. We're going to figure out where the heck our other stuffy stuff's supposed to go. Here's code properties. We're gonna do a good old build here. File project. Pico. Oh dear, non-existent target balancer. Uh-oh. FreeRTOS, we're going to check out v and dot 4.0, I think. Is that what the other one is? Kernel only, yeah. Oh, there's an 11. Okay, there's some new stuff. Yeah, check out, what if we did v 11.2.0. What's in that? Nope, no realloc. Okay, that's sad. Okay, now let's see what happens if we try to build this. And also, something went wrong up here, because project, PyBot firmware, oh, languages. I think that's CMake, project, language. Languages, it is plural. Okay. Oh, I must have missed one. Source CMake. Ah, yes I did. Alright. I bought firmware. CMake. Build. We still haven't managed to configure anything. Yes, here we go. PyBot firmware. That's probably going to be a bunch of things that don't link correctly because Pico... Oh yes, this probably doesn't work. Oh, it's in examples. Why is it building? Right, because it's building the holding thing and not just the one that we wanted. Compile. Yeah, we don't want to build. We don't want to build the examples. How do we not build the examples? But we... Much build type. Oh, yeah, there. Make. Don't want to use Copilot. Pico SDK 220. Okie dokie. Yeah, I mean, it's not happy because it's trying to build these PyBot firmware, but I only want to build this one. Oh, that's annoying. Build. Oh. How about firmware? Compile. Expecting build.ninja, but it didn't work. Okay, well, we shall nuke the build folder. And try this again. Compile. And it's trying to add the stupid freaking examples again. I only want to build the freaking... Don't show again. Okay, hold on. Maybe I've done something wrong. Who's asking for that? Let's grid CDMA. Examples. Interesting. Wait, why has this not caused me problems before? Why is this causing me problems now but not before? That's a good question. I don't want CY43 Arch anymore. I'll do a bunch of other shit that doesn't work now. Yeah, I don't want packets. I do want FreeRTOS, but LWIP, IPv4. Yeah, I don't want any LWIP stuff. Quadratron encoder. Yeah, I don't want that either. We are going to need some kind of encoder support, but leave that out for now. File. Bunch of LWIP stuff's not going to build correctly because we don't want LWIP anymore. So main, and delete all of this. Honestly, we delete the Euler, yeah. So we actually just delete all of this shit. Not shit, yeah. Delete that. Velocity doesn't make any sense. Velocity. Gravity, Euler. Vec3. Where's my Vec3? You know? What a definition. How did I define Vec3? Oh, I probably defined that in my... I probably defined Vec3. We'll just comment that out. All right, yeah, so we keep that. We keep... Well, we can't do any printf stuff anymore because... we can't do any we can't do any printf stuff because yeah, like we can't. All right, we can't do any printf stuff because we're using that as the FreeRTOS transport. Not FreeRTOS, as the micro-ROS transport. And so to do, we're gonna have to calibrate our IMU, calibrate IMU. All right. 5-foot buffer, your configuration task just needs to be destroyed. Set motor, do the thing. Yeah, configuration task needs to be gone. Standard IO mutex. Have to Q input mutex. What does that even do? What does input mutex do? All right, nothing right now. Yeah, we don't even need configuration task. Yeah, and then main task isn't even something we need to be doing right now because that's do micro-ROS stuff here. Micro-ROS. We'll might as well leave tilt sweep task there because that's just a fun one. That's just stuff. Okay. We'll migrate main task much further down here. Set up the LiDAR, to do hunt and synchronize, yeah, all that fun stuff. Oh yeah, and then it's a LiDAR task handle. We wake up if we receive data from that stuff. We delete all our TOS thingies. Create the main thread. Let's create our other threads, because why not? Tilt sweep task. Okay. Initialize that to 0. Initialize this to 0. Null pointer. Tasks. And maybe we stick the main all the way at the freaking top. Maybe. tilt sweep task. We'll just do it at the very end here. All right. All this junk that we've decided is this is the LiDAR DMA buffer structure. All right, and basically this is a, since I did this off stream, I might as well walk through it. So this is a there's a static buffer allocated, aligned to its size. We default this to 1 kilobyte. Each data packet that comes from the LiDAR is 22 bytes long. And then we're basically implementing a ring buffer here. I should create some C++ class to wrap this at some point, but not right now. Basically, it is a... it's just a ring buffer. This is just to handle some ring buffer structures. And the idea is there's 2 DMA channels. We'll come down here to set up LiDAR. Basically, it turns on the UART, UART 0, subscribes to the LiDAR. It uses 2 DMA channels but in a ping-pong fashion. So what that'll do is that each of them will copy 22 bytes from the UART into the buffer, and then trigger the next DMA channel. And basically, when one's reconfiguring, the CPU has the time to go reconfigure the other one. So each channel, moves 22 bytes, and so when one moves 22 bytes, it then wakes the CPU up, and then the CPU has the next packet window plus the UART FIFO size to set up the UART the DMA channel again. So there's 30 odd bytes that it has time to reconfigure. So either way, basically each DMA channel copies the data, and then it wakes up the LiDAR task saying there's a LiDAR packet. All right, so we got that, and there's just some helper tasks to help with processing the ring buffer. And so we might be able to, I don't think we can compile quite yet. There's still going to be some missing things. Printf guarded. Yeah, we got to deal with all this printf guarded stuff. Printf guarded. Yeah, LiDAR stuff. Okay, yeah. Compile. Still failing because ulongmax not declared in the scope. C limits. Still not compiling, which is probably fine. Oh. Get motor velocity. We'll just comment that out for now. Actually, sorry. Just in case. Return 0. There we go. We're building. We've commented out everything that we're not commented, or deleted anything that we're not using. So yeah, so now let's start copying in our FreeRTOS stuff. Dependencies, copy -r .. slash Pico, no, Pybot, micro-ROS, lib micro-ROS. Copy that to here. Okay, and then we're going to open up our dependency. Oh no, dependency CMake lists. And we're going to open file. We're going to come back up all the way. We're going to go to Pybot here, micro, do all the things, CMake. Open up all these stuffs. Okay. We're going to also open file. FreeRTOS kernel, portable memory management, heap 4. This goes to the realloc thing, which this is disgusting that we copied this in here, but why not? No, I just want to copy it. Okay. We're going to go to our FreeRTOS kernel. I'm going to go to portable memory management heap 4. Yeah, I knew that wasn't going to be a thing. All right. Viewport free. All right, heap 4. All right, cool. So all we need to do is set some stuff. We go to our CMake lists. We're gonna target compile definitions. All right, that's good. And then what we're gonna do is come up here. We're gonna actually what we're gonna do here too is that we're gonna do ROS. Okay. I'm gonna do task idle priority +1 U. Define the rest of these as 2U. Keep the main thread as the lowest priority, just because we want it to do other stuff if possible. All right, so now we've got quite a few things available. We'll do. Oh yeah, we want to add our micro-ROS library or dependent. Yeah, whatever. We want to say that. Hold on. We want to say that. Wow, I'm really just having a moment here. Okay, so we want to go to the dependency CMake, which we closed on accident. Okay, that's why I can't find it. This one, dependencies. Add the the correct FreeRTOS thing. Add micro-ROS library. I'm going to do add library micro-ROS imported, which I'm trying to remember off the top of my head. CMake add library imported. Right. Add library imported. There we go. Add library static imported, and then we're going to say set target properties. Micro-ROS properties. We're going to do imported location is CMake current list dir / lib micro-ROS / lib micro-ROS.a. Ordered, and then includes. I'm trying to remember. Okay, cool. And then we would say target include directories micro-ROS public, and we do build interface CMake current list dir /lib micro include. Oh, interface. Okay. We should be able to link to micro-ROS in here now. Do a compile. No, we can't. It really didn't like that. Failed. Not find -L micro-ROS. Okay. That's fine. Oh. Right. Oh, no. micro-ROS. micro-ROS. That should have been fine. Compile. Can't find micro-ROS. Shouldn't need to find micro-ROS. L micro-ROS. No, it should be in dependencies. Oh, it's because I did this wrong. No. Set target properties. micro-ROS. Imported location. Alright, I did something wrong here. Include directory, static imported, set property, target, property, imported location. Okay, hold on. The micro-ROS.a. What did I do? I did something funky. What did I do wrong? Do I just delete the build folder? Pile. Clemson is very unhappy. ROS kernel, portable. What is even going on? What? What? Cannot find source file. I don't even... Clearly I've done something wrong. You make lists. Portable, third party, community supported ports, GCC. No. TC. Huh. Come on. What is going on? Kernel path, cache string. Where is the C routine thing even coming from? Like, what? Find dot dash name. Kernel. Fine, we're going back to Claude. Do. Okay, fine. What? Who is even pulling in this croutine.c thing? Like, come on. Hold on, what if I did this? Oh, so if you do it up there, now it works? Yeah, okay. But it's still trying to... It's still not importing this lib micro-ROS thing. Imported location. Fine. Micro-ROS. Micro-ROS. Lib micro-ROS. ROS.A, static imported, set target properties, imported location. You make fails to link no such file or directory. Imported location. Oh, global. Is that a thing? Oh, that was it. Okay. Fine. Only visible the directory is created and it's subbed. Okay. Fine. Okay, that's what it was. Perfect. We did it. Okay. So, is Claude your cat? You ask your cat for code help? Yeah, sometimes. Alright, so. Cool. We've now got... okay, so we've now got new file. Pico UART transports. Or Pico, no. Pico UART transport. Pico just serial. Pico transport. Yeah, whatever. We're just gonna call this Pico STDIO transport because that's what it is. Yeah, file, new file. Pico STDIO transport. .c. H. Transports. H. Pico STDIO transport H. Okay, and then Pico serial transport. Change all occurrences to STDIO transport. Okay, we'll have to review how efficient or not efficient some of these are, but it's fine for now. We'll edit this as we understand them, right? So we'll come over to micro-ROS SDK. Oh, right, we don't need those anymore. That one anymore. Don't need that one anymore. Main or source, and we can do Pico STDIO transport.c. Compile, and it built. Cool, which means we're linking correctly. All right, I like that. I like that. Something's working at least, right? Honestly, we don't need any of those, right? Okay, we do need stdint.h. Okay. Alright, hold on. Okay, there we go. That's what I wanted. Compile, do. Okay, perfect. Transports. No time. Yeah. Okay. Those are transports. Bring our Pico example thingy. We're gonna do that. We're gonna do our allocator shit. Okay. Set custom transport. So we'll do bring in this stuff to our main. All right. I'm gonna delete that. Compile. Still should be fine, right? Yep. All right. Nice. Okay. So we're gonna need alias. We're gonna need to include our Pico stdio transport. Okay, anyway. Now we're going to do the allocator. Okay. Yeah, we're just copying stuff over from our other thing. All right. So main thread, IMU, LiDAR thread. Okay, cool. And then we're going to tight loop. Yeah. Main task to do micro-ROS. Right. We need to copy over our allocators that we set up. And main, we'll just implement them up here, you know, whatever. No, why not? Why would we do that? do these down here. You know, let's do something absolutely freaking cursed, and use lambda functions. Yeah, we'll just be cursed. We'll just be absolutely freaking cursed here. So we'll do this. We'll do set up an allocator, and then we'll basically say, yeah, this will let us do allocator.allocate equals a thing. Yeah, nice. Allocator.deallocate. Deallocate equals that. Pointer. Pointer. Dot reallocate. Void pointer. Oh, this is cursed. But it's funny. And then we can do allocator dot zero allocate. Again, we can comment out state. So at the end of the day, realistically, all we're doing here is we're just bridging these. All right, I love it. Oh Jesus. Okay. Micro-ROS allocator. Set up micro-ROS transport. Honestly, we can just say set up micro-ROS. All right, we'll just do that. Set up hardware. All right. Perfect. Set up micro-ROS, main thread. We'll copy this code over. That is the actual main thread. And we'll do something here. Okay. Allocator. Default init. No. this thing. Hold on. ROS IDL. Nope. That's right. And timer. Support. Milliseconds. Callback. Uh-oh. I didn't copy the whole thing right. Oh, yeah. Oops. Micro-ROS, message.data, do that. Main. Spin some. I'm curious. I'll do this picobot. No, actually, so we'll say picobot firmware node. What do we got here? Interesting. Anyway. All right. So, continuing along. Spin some. Let's copy over the whole timer callback. This one little piece of timer callback thing. Just to fucking whatever. All right. So timer callback. Oh, you know what? We can even do another global freaking thing here. RCL timer. Timer 64 last call time. So RCL ret t equals RCL publish. Publisher. Message null. Message dot data plus plus. All right. So we got that. Publisher node, ideal get type. I think that might be it. I think that might be what we everything. Start scheduler. Yeah, here we go. I think this is it. I think we copied the existing publisher logic, so like it's just going to be publishing the same thing as the other stuff. But ideally we can run this on our chassis controller. And we'll see something. Okay. Oh yeah, we need to delete that bit of garbage. All right. No compile. Did that work? Aww. Think it didn't work. All right. Oops. Oh, did I goof something up here? Hold on. Oh, I did. RCL timer 2. How did I mess that up? Okay, compile. Oh, I also missed another thing. RCL ret. Compile. Warning, it's deprecated, it's not casting incorrectly, timer at default. And the PV port realloc thing is not happy. Okay. Memory management, heap 4. And yes, and we gotta put it in our portable, or some header, right? Compile. It failed. Okay, undefined reference to standard I/O transport. Read. Transport open. Oh, lovely. STO transport dot C. Oh, what? Why? How? Huh? Okay, maybe this is a little more interesting than I thought. There we go, as is the extern C stuff. Okay, cool. Call timer init default 2. That's fine. But it built, which means that we can try to deploy it. So we're going to copy the so we're gonna SCP build source pybot firmware.uf2. I'm gonna send that to pybot.local. I think that's what I called this robot. Maybe it's Pico Pybot, Pi5bot. I don't know. Let me go look at my. Is this Pi even booted? Yes, it is. It is booted. And okay. Let me check my DHCP server. View leases. Oh, yeah, it is called Pico Pybot, like a dingus. Okay. X. We got term equal. Or is it? It's called stinger.local. It's called stinger.local. That's what it is. Okay. Eval. Not great. Okay, we're gonna try SCP. I bought firmware to stinger.local. All right, now we need term. Okay, now we got Pico tool, right? Bag files. All right, we need Pico tool from somewhere. RPI Pico tool. Git clone Pico tool. No Pico. That's unfortunate. That's a problem. That's a problem. Okay, actually, on that note, okay, hold on. Demessage. Did it blow up? No, it didn't. Okay. What we're gonna do? We're gonna flash all. I mean, Pico tool's definitely what we would want to use, but we're going to flash this using my debugger. Ow. Okay, I was plugging that in upside down. Okay, that won't work. Ow. Keep nicking myself on the LiDAR. Okay. Alright. So, plug in our debugger probe. Now that I've turned it upside down on accident. Alright. Alright. So we're going to say Pico tool, flash using SWD. Perfect. That doesn't look right. Flash probe, padding image, adding extra range. That doesn't look like it worked, right? Did it? Oh, extra erase range. Oh, okay. Interesting. All right. Oh, did I not edit the firmware? Firmware config. Oh! We didn't edit the firmware on here to enable the freaking oh yeah, we forgot to do that. All right, cool. Oh great. Sudo vim. So what we'll actually do here is just do all. Okay, wait for that to come back up. Okay, we're waiting for this to boot back up, and hopefully we'll get... See if it's back up yet. Nope, not back up yet. Oh, yes it is. Hopefully we see, yes, we see the Pico, which is good. That means we can do... We'll remove the PyBot firmware. Eco tool. Is there a CMake? Yeah. CMake dash D dash G ninja. CMake build type equals release. Be build dot. sudo apt install ninja build. Oh, that's great. Alright, cmake, no, git clone, git https gov.com raspberry pi / pico sdk 2.2.0. Yeah. Okay. Pico tool. Oh. It's path. Okay, anyway, let's boot up our, oops. Let's boot up our micro-ROS agent just to see. I don't even know if I have Docker installed on here. So yeah, how do I get the micro-ROS agent? Micro-ROS agent install. That's not what I want. Okay, that's different. Well, that's curious. Okay. Well, anyway, source, opt-ROS jazzy setup, and then we're gonna make dir micro-ROS workspace. Wow. Make dir micro-ROS workspace. ROS setup. We're gonna do update dependencies. Make sure we got all that stuff. We also need raw step. Okay, interesting. Okay. Install from paths source. Yeah, because we don't have Docker installed on here, so we're going to try to figure out how to build the agent normally. con build, local setup. Alright. Well, we'll call it in about 20... We'll call it 11 o'clock tonight. So, still moving along. Moving along. Okay. There. Alright, cool. There we go. Up, still installing shit. Okay. That's fine. That's fine. There we go. Up, still installing shit. Alright. Much slower on the Pi than my desktop. Perfect. There we go. Colcon build. Perfect. Source install local setup.bash. Oh, shit. Okay. I did that wrong. Look at that. Look at that. I put the freaking micro-ROS workspace in PicoTool. Okay. Micro-ROS workspace, RMRF build, install log, colcon build. Oh, I gotta resource my environment. Hold on. ROS workspace source. Oh, jazzy. Colcon build. Source. We're gonna do a ROS2 run micro-ROS setup. Create agent. Workspace.sh. And then just to run micro-ROS setup build agent.sh. Let's see what that does. The fact that the LiDAR speed regulation is still working after we flashed this this code means that at least part of the firmware came up correctly. Alright, still building. Should probably just install Docker. I mean, we will install Docker on here eventually, just didn't know if we were going to do that quite yet. We'll have to clean up a bunch of this stuff. Your C includes, C includes, back to C includes. There we go, building, still building agent. PyBot firmware. Alright, continuing along. Where'd my water bottle go? Oh, there it is. Well, sitting here waiting. building. I mean, I would love to publish a laser scan tonight. I would love to get to publishing a laser scan tonight. That would be so awesome. See what happens though. Okay, well, we'll see what happens though. Let's look at how we'd even do that. Standard messages at 32. Oh, here we go. We finished running the micro-ROS. Okay. No, we're going to do a pico tool. Or, sorry, we're going to do a .. pico tool. Build pico tool. Info. Reboot. Oh. Sudo? Alright, so we've rebooted it. Alright, and then... Okay, so we should be able to do micro-ROS. Oh, we gotta do a source. Install local setup again, .bash. We should be able to do a micro-ROS agent. Serial dev tty cm0. Nope, didn't find the command. That's unfortunate. ROS2 run. No. Build micro-ROS agent. Oh. It's all underscores, isn't it? Nope. Gosh darn it. How do I even... If we... Good old source... Jazzy. Micro-ROS workspace. Source. Install local setup. Micro-ROS. Build ROS agent. Serial. Dev tty acm0. Come on, connect, please, please. Be really nice. Might have timed out here. There we go. We got micro-ROS. Hey. All right. So we're running this out on the network. So hopefully, if we bring up Docker, PyBot Docker run do RQT. Yeah, perspective, plugins, topics, topic monitor. And we got a Pico FreeRTOS publisher. I thought I renamed that to PyBot, but I guess not. I did not. It's still called publisher. Okay. So, in order to demonstrate that we're actually getting data from the robot, interesting data from the robot, what we'll do is rather than calling it this, we'll kill that. We're going to call this LiDAR RPM. And rather than doing this data plus plus, what we shall do is it's going to be We're going to call this... I'm going to call this message.data equals RPM. We'll say compile that project. It'll still run, and then we'll say Flash project. That's coming up. All right. I'm going to start micro-ROS. We're going to run our QT. LiDAR RPM. There we go. We want to see 300-ish. And actually, just to make sure that, to see that this is publishing even more frequently, what we can do is, rather than running it in this mode, what we can do is, and this'll test our, rather than using this timer thing, we can actually say publisher, RCL publisher, LiDAR RPM publisher. Standard messages, message, int32, LiDAR RPM message. We can come in here and say node init, and we say this is PyBot firmware. No, what was this called before? Before we changed it, it's called just publisher, right? Firmware publisher. And we'll do our message.data plus plus. And yeah, we'll leave that. But what we'll do now is we shall add timer. We will do a RCLC publisher init default LiDAR RPM publisher node ROS IDL get message type support std messages message LiDAR RPM message int 32 be PyBot LiDAR RPM. Okay, like that. LiDAR init. I'm not sure, is there a node? It's the only time node shows up, init default. Alright, well, you know, we'll just still do that. Instead of setting up this message, what we'll do is at our RPM message.data equals RPM, and PyBot firmware, why not? LiDAR RPM. And then we'll say we need to use this publish command. LiDAR RPM publisher. Maybe that'll compile. Nope, did something wrong. Oh, I think that was not message. I don't think that was message in terms of our message. I think that was message a string subfolder. Yeah, okay. Compile. We're gonna flash project. Do that. Alright. We're gonna bring our QT back up. Yeah, there we go. Oh, shoot, something broke. Oh dear. Something's not happy. Something's very not happy. Oops. I see. Oh, that's what I did wrong. That's why it was freaking out. It's because I can't publish until the thing's connected. Okay. Ping agent. None of this stuff is actually loaded until... Okay, that's fun. That's fun. Okay, hold on. Initialized. Bool. Micro-ROS up, false. Alright, I'm gonna do a micro-ROS up equals true. Okay, here we go. Hold on. If micro-ROS up, then we gotta figure out a better way of doing this. Have the main task fire off the other threads, basically. Oh dear. not good. Why does, I'm being quiet here, sorry. Why does this not, why, okay. How come setting the LiDAR speed is bad when we're sending RCL? How long does RCL publish take? That's a good question. Okay, declared with attribute something. Okay, maybe if we only sent it like once every couple of packets, I guess, you know, once every, well, we get 4. What if we send it every 90? There's, all right, int I equals 0. If plus I equals 90, and we send a message equals 0. All right. Compile. ROS project. There we go. Yeah, 5 hertz. I mean, that's what we want. That's how often the LiDAR is supposed to update, and we get 4 distance measurements per per spin, right? So, or we get each of these little messages gives us 4 distance values. We get 360 distance values per rotation. So divide by, yeah. You get 90 messages per rotation. So if we send 1 packet every 90, we should see a 5 hertz message rate, essentially. Which we do. If we look at that, monitored. There we go. Perfect. So we are micro-ROSing. We are sending data. Jimra. Perfect. Okay, we are micro-ROSing. There we go. Data's coming up, and if I was sending 1 message every, 90 per spin, so 5 times 90 would be, 3 or 5 times 90. Sorry, 5 times 90 is just under 500, right? They're somewhere around 500. Not exactly right, but minus 50, so you have 450, right? So we get 450 little messages per eon. So we couldn't send 450 messages across per second, clearly. There's also some other stuff that we can. Sorry for being quiet recently, but all right. So the one of the other things we could possibly end up needing to look at too, is that by default the Pi Pico STDIO implementation is pretty slow. There are ways of speeding it up, like increasing some of the buffer sizes and such. But I gotta actually look into. There was this one project called Fast Serial. We gotta actually look into that at some point. But now that we are clearly, but now that we're clearly, able to send some data, how about we try publishing a laser scan? So we've got this running. So another thing I guess to say is this LiDAR positional PID thing, or this positional PID LiDAR PID thing. is to control the RPM of the LiDAR. It needs to be spinning at 300 RPM is the specified, how much, 5 rotations per second, essentially. But because this is an old LiDAR, we have to control the motor RPM ourselves, one of the things we had to do. So this PID loop basically reads the RPM message out of each of the LiDAR packets and sets up that controls the velocity motor. It starts it kind of slow. The idea is to spin it up just enough that it'll start spinning packets, because if it's not spinning at all, it won't send any packets. So we set it at a low speed, which we saw that one when we did this without having an update. We saw that it was only turning at like 127 RPM, and that's way less than it's supposed to go. But we also noticed that if we tried to send 450 messages per second, it would just lock up. Or I don't know if it locked up, but something went terribly wrong in the LiDAR, just immediately maxed out. Anywho, now we've got there's also this LiDAR synchronize thing. Like, we can guarantee that when this returns, we're at the very first packet. So what we need to do now is set up a laser scan message. And let's see. LiDAR task. So let's start looking at setting up a laser scan. We're going to create another publisher here, RCL publisher. Publisher T, LiDAR, LiDAR scan publisher. Standard, okay. So we've got this standard messages. We're looking at this. So we've got dependencies, lib micro-ROS include, I think, maybe it's in standard messages. I don't know. A message. No. Sorry, it's probably in sensor messages. Yeah, there we go. Sensor messages, message, laser scan? Laser scan. There we go. So let's look at the laser scan message. Laser scan ROS message, ROS2 message. Laser scan. So we've got standard message header. Timestamp is the acquisition time of the first ray in the scan. Engelmann. Oh dear, this is going to take a bit. Now the other question is on this micro-ROS stuff, how do we set a subheader, or what do arrays look like? But yeah, laser scan. What does that look like? Vim. Oh, detail, laser scan struct. Well, fuck. Sensor messages, message detail. Alright, I'm really mucking this up. Hold on. Where does this freaking... Okay, sensor messages, message detail, laser scan. Message detail, there we go. Laser scan. Alright. There's also some irony of using Vim in a terminal inside of VS Code. Anyway... Anyway, that means we need to include sensor messages, message laser scan.h. There we go. That does a thing. And we got sensor messages, message laser scan. Is that a thing? Sensor messages, message laser scan. LiDAR scan message. All right. Well, let's actually just open that. No, oh, you know that. All right. Include, forced to include. Okay. There we go. All right, find that. Built-in interfaces time. Okay, well, we're good. So the curiosity is C float sequence. Oh dear, primitive sequence. Number of stuff allocated. That's a curiosity. Okay. Okay, how does this work? Type data capacity. Looks like we have to allocate our own array of data, I guess, maybe. That's fine. That's not a problem. Minimum range value, maximum range value, time increment, time between measurements. If your scanner is moving, this will be useful interpolating position of 3D points. Time increment, that's fine. It's probably in seconds, right? At all. Timestamp. Yeah, length, size, capacity. Okay, number of allocated bytes, right? Okay. Anywho. Well, back to main here. All right, so if we have to do this ourselves, that's fine. LiDAR scan storage, right? All right, so we've got LiDAR, LiDAR scan message dot intensities and range intensities. All right, dot data. So we'll do float. This is always float 32, right? Yeah, float 32 or float scans. That's going to be 360 scans. Float intensities. It's also going to be 360. Dot data equals intensities. LiDAR scan message dot intensities dot capacity. The question is whether this capacity thing is in bytes or if it's in number of allocated items. Okay, perfect. Capacity equals 360. Okay, perfect. I don't know what order that's supposed to go in. Yeah, data size capacity. Perfect. Data size capacity. All right. Put that up here. Ranges. And this actual message thing up here doesn't actually need to. I mean, that publisher does, but the RPM. Okay, perfect. The publisher has to be public, but the scan doesn't. Okay. Scans. Okay, I like that. So we got const char link name equals. We're gonna just use base link because that's an assumed like thing that's present. So we got LiDAR scan message dot header dot frame ID. data equals aim-id LiDAR scan message dot header dot aim-id dot size equals 9 LiDAR scan message header frame capacity equals 9 LiDAR scan message header stamp nanosec. Have to figure that out here at some point. And all right, perfect. So now we need to do. Okay, so we got I. So we know when we come out of LiDAR synchronize here, our scan buffer is fine. So we're going to say int index is 0. We're just gonna index 0. All right, and then let's look at the packet format for the. Yeah, so let's look at the packet format for the LiDAR data. All right. The distance is in distances in millimeters coded to 14 bits. Minimum distance is around 15 centimeters. That's fine. Okay. Signal strength. Perfect. Okay. Strength warning. It's actually a good question, this laser scan message. Oh, here we go, also. We've got LiDAR scan message dot angle increment equals, and it's in radians, so that would be pi divided by 180. Right? Yeah, because it's 2 pi over 360 or pi over 180, right? Laser scan message dot angle min is 0. Also 0, I think. Angular increment, LiDAR, scan, message. Oh, we already set that. All right, would be angle min, angle max would be 2 times pi divided by 360.f minus actually, honestly, LiDAR scan max equals 359 f times LiDAR scan message dot angle increment. See if that even works. I may not be getting this right. I've been doing this right. Frame ID. Oh, jeez. How does this work? Stir dupe. hate the idea of that. Okay. Time increment between measurements. If your scanner is moving, this will be useful. Okay, time increment will be LiDAR scan message dot time increment equals will be, that's 5 RPM, right? So it will be 0.2 divided by 360, or divided by 360, right? Yeah. Yeah, divided by 360. LiDAR scan message dot scan time equals 0.2f. Okay, time between scans, time between measurements. If your scanner is moving, this will be useful. And then we gotta deal with range min, range max. Okay, so we do LiDAR scan message dot range min equals infinity infinity LiDAR scan message dot range max equals negative infinity. Okay. And it's in meters, right? Yeah. Okay. So, continuing along, we've got. I think we've set up all of this correctly. And you know what? Before we even start decoding the laser scan, if let me do index plus plus if index plus plus equals 90, then we do if micro-ROS up publish, then we do index equals 0, do that. We do all this. We do the reset. Publish message when scan is complete. And then we can do RCL publish. Okay. That LiDAR RPM message can get copied into here too. publish laser scan. We do RCL publish. LiDAR scan, publisher. LiDAR scan message, no. Okay, if micro-ROS up, if compile. Okay, cool. If index is 90, and we publish the thing. We also need to figure out how to assign the stamp to it. So the scan will be, or the stamp should be, I mean, we can get, we have a nanosecond counter, don't we? I mean, that was even part of the transport thing here, right? Yeah, clock ID, time spec. Yeah, time US 64. Okay, interesting. LiDAR, scan message. Timestamp is the acquisition time of the first ray. Okay. Nice. Okay. Message. Header stamp dot seconds equals time divided by 100, 1, 2, 3, 1 million, right? LiDAR scan message dot header dot stamp dot second dot end sec equals time. Okay, we'll just say now. Now plus. It's gonna be now modulus 1 million. 1, 2, 3. 1, 2, 3. Now modulus 1 million times 1,000. Okay. Time, oh, time US 64. Okay, and this is going to be the 0 index. Okay, cool. Theoretically, we see header timestamp is acquisition time of first ray in scan. Okay, perfect. I like that. Let's see if we can even send all this stuff. Because, all right, so compile. And then if we do a good old flash. that's not good. That data's only coming out. At 3.5 hertz. That's, oh, there we go. 4.98, 4.99. All right, cool. We didn't configure the publisher because, of course, we forgot to do that. So we've got the RCLC publisher, and it defaults. LiDAR scan publisher node. ROS IDL. Get message type support. Sensor messages message. Laser scan. That built. That's scary. All right. It's up. Laser scan. Ooh. That is publishing at not a happy amount. Oh dear. It looks like we already overloaded our transport. Welp. That's unfortunate. That's 5 kilobytes a second would be 50 kilobit, which is about half of the theory. We're gonna have to play around with this next time. We really are. But anyway, let's populate the data that's in here, and then we'll see if we can actually see this in RViz, and then we'll call tonight when we see that. So kill this agent. We'll look at this. We'll go back to our message definition here. For our laser, okay. I'll come down here. Then we're gonna say publish laser scan. Actually, now we got to do all of our math here. Oh shit! Something went terrifically wrong here. Flash project. All right. Again, we gotta figure out what's going on. Anyway. All right. So, we do that for the time, and then we populate compute distances. Okay. So we've got. Each data is 4 bytes long. All right, so we've got so here we're gonna do something nasty. We're gonna say struct okay, struct scan, or sorry, struct LiDAR ray, and so we've got uint 16 distance, and that's going to be 8, 9, 10, 11, 12, 13, so that's what, 14 bytes, or 0 through 7, so that's 8, 9, 10, 11, 12, 13. So that's 6 plus 8 for 14 bytes. We got bool, strength warning. It's 1 byte. Bool, invalid warning. 1. All right. Then we got uint 16 strength. We got. All right, cool. That'll give us a 32 byte thing. I'm gonna say. Struct LiDAR array. Struct LiDAR, or we got LiDAR array. Rays equals static is reinterpret cast LiDAR array. Buffer 4. All right, so we say raise, so we got if 0 j less than 4 j plus plus. We've got if raise j actually, I goofed that up. If plus plus index is 90. Actually, index plus equal 4. If index equals 360. And we publish. Okay. If raise j dot, well, we'll just assume every scan's good, which is stupid, but for now. So we got float distance equals raise j dot distance equals float distance times. Because these are in centimeters, I believe. It's in millimeters, so we need to multiply by, or sorry, divide by 1,000, because it once each of these distance floats is in meters. Got float intensity equals I don't know what the intensity is supposed to map to. Device-specific units. Okay. So intensity equals raise j dot intensity. I'll just call this intensity. We'll actually say scans I plus j equals there we go, or not I plus j, it's index. All right. So now we do a for int I equals 0, I less than 360, I plus plus, if LiDAR scan message dot range min If scans 0, or if scans I less than range min, we got LiDAR scan message dot range min equals scans I. If scans I greater than LiDAR and message dot range max, LiDAR scan message range max equals scans I. Okay. And now publish. Should be able to compile that, I think. Anywho, alright, we did that. That's fine. So, yeah. Okay. In theory, this should be good. This should do us. Compile, run. Well, we need to make sure we re-enable. Set mode. Okay, cool. Okay, cool. I don't see anything on RQT. That's unfortunate. Okay, RQT. Uh-oh. Oh, there we go. Laser scan. Alright, ranges. Cities. Okay, well, let's try RViz. See what happens. Oh, it died. Alright, so we're going to say... Actually, we're going to give ourselves another Docker container to look at our QT. Docker... projects, Pico, Pybot, Docker, run, RQT. Plugins, topic monitor. That's too high. I'm twiddling things because having trouble getting this thing to work, or not getting it to work. I mean, yes, but 289. That's close enough. Okay. So we're going to say I'm going to add a laser scan. Okay. It's fine. Why is it showing 0 points from 0 messages? Fixed frame map. We might as well attach the... Might as well attach map. Might as well attach this to map and not baselink map. 3, 3. There we go. Look at that. We've got laser scans. Look at that. It's coming in at a horribly low data rate because something's not happy, or we're overloading something on the we're overloading something on the Pico's data interface. But let me put this in the middle of the floor. Yeah, hold on. Let me put this in the middle of the floor. Yeah, there we go. All right, so we've got laser scans. Oh my gosh. All right, so this is my chair. Kind of scooching along right here. My foot. I'm going here. What is the... Oh yeah, and that's the other side of the room. There's some boxes over there. I wonder why these dots are not happy. But that's fine. That's fine. Wonder what we I wonder what I should define for oh, sorry. I wonder what the correct thing for scans that aren't the sorry. I wonder what the correct value for scans that don't measure correctly are. Do we say nan for distance or something? I don't know. Showing 359 points. I mean, it should be throwing 360 points, but whatever, I guess. But yeah, we've got a laser scan. We have written a piece of code. We've used micro-ROS on our Pi Pico. We've read the laser scan out of the XV11, converted it into a micro-ROS message, published it. Admittedly, it's running really slow, and we're gonna spend the next couple of minutes see if we can actually do anything about that, like in the last 20 minutes here. But yeah, okay. So let me grab the robot again. And I bet that debug. Oops. I will be right back. I need to take a quick bio break. But yes, we've got a working LiDAR now. Look at that. All right, so we're going to try to spend the last couple of minutes here before midnight trying to tune some of this stuff, or tune the STDIO thing. So we're going to kill the proxy, and then we're going to... sorry, and then what we're going to do is do something. Yeah, wow. What am I even saying here? Hold on. One of the things we should probably do, just to keep the regulation thing here, is probably push these to another thread so that the LiDAR can still be decoded whilst all this is running. Anyway, so what we'll do is right. All right, so let's look up the... Or actually, before we even do that, let's go back to the transport here. And this put char thing is really slow. So we're going to do stdio put string. We're going to do... This is going to be a buff. Okay, stdi, or hold on, put. Hold on. Okay, I think this is stdio put string buff len false false. Return the number of characters written. So if len, so we got auto len equals put string, or actually this is C. So int len put string, we'd say if len not equal, or actually, sorry, int ret, if ret is not equal to length, we're going to say error code equals 1, and then return, or return I, and then just return ret. No, error code equals 1, return ret. The which thing failed. So yeah, so we're going to start by doing that, and then seeing if that helps at all. I'm going to say flash swd. All right, we're going to start up the agent and come back over to RViz if it's still up. Doesn't look like it's publishing anymore. Which is not good. RQT. Ah, yes, laser scan. Oh, hey, look at that. And it's running because we upped the, we used a more efficient scan thingy. All right, so that'll let us do now. Okay, so let's restart RViz. We're gonna project it 60 things. We're gonna add a laser scan. We're gonna listen to laser scan. And now it's updating much faster. Much, much faster. And then listen to Pybot LiDAR RPM. Oh, of course me listening here makes it not work right. Oh, that, what? Alright, well I don't really... Alright, LiDAR RPM, we'll listen to that. Listen. Yeah, it's publishing at a reasonably okay rate, you know. 4.8, whatever. All right, so we are seeing a much higher rate now of laser data, which is very good. And that is just because we're using a more efficient way of writing to the buffer. So let's see if we can go any further. And because that's working much better now, I bet I can reintroduce the LiDAR control, the laser scan control main, PID control of the LiDAR motor. There we go. That's what I was trying to say. All right, Flash project. That restarts, and we're scanning again. We're going to listen to the RPM. Hertz. That doesn't sound right. That's updating more than once a second. That's fine. Back up to RQT. Well, yeah, let's see what the debug here. 4.8 hertz. Yeah, there we go. Laser scan. No, don't do that. I'm gonna listen to, yeah, RPM. Yeah, that's publishing it. 5 hertz. Nice. All right. 1.8 hertz. Yeah, there we go. So we gotta figure out what the correct thing to do for whatever you call it. Sorry. To figure out what the correct response is for laser scans that aren't quite measuring correctly. And honestly, like, another thing that's kind of curious is what is angle increment. What if we set this also to 0? $359 points. That doesn't look like it moved. I just want to know why it only thinks there are 359 points in this scan. That's a little strange. Unless it expects like 361 on size and capacity. Who knows? We'll see what happens. Well, that certainly didn't work right. Really didn't work right. Yep, that did not work right at all. Seriously? How would that even have affected that? It can't have. The answer is it didn't. Okay. Okay, so I'm still having trouble with the PID loop because it's, I don't know if it's somehow crashing somewhere. But anywho, we are definitely getting a substantially higher data rate. We're going to listen to the RPM, see. Yeah, 286, 288. Just a laser scan. What does that look like? Boston. Hurts. Something's broken. Something's not working right there. Anyway. It's really not working right there. Anyway. I'll look at... Yeah, this is still doing its thing. Oh. Listen to that. Publish. Something has gone a little screwy. So yeah, let's look at other... let's look at some other things we might be able to do. So we'll minimize that. Okay. So... Well, that definitely helped an absolute metric boatload. Let's see. We've got ROS topic, bandwidth, laser scan. Oh yeah, it was ROS something. ROS2 topic. Oh, bandwidth. Laser scan. Oh, oops. Well, shoot. There we go. Let's see if we get data. Yeah, laser scan. Let's do topic list. Topic, bandwidth, laser scan. And, oh, that's really... Something's not happy. Something is definitively not happy. Okay. Probably RViz doing a thing. Trying this again. All right. That's up. That's up. ROS topic list. Bed again. Yeah, now it seems to have gone down and is not happy with me anymore. All right. Well, it is midnight, so let's call it for the evening. Why did it break right at the last freaking second? That's so annoying. What if we restart? We restart a friggin' container. ROS2 topic list. Yeah, nope, they're gone. What the heck? What the heck? What is going on? Why? Why though? plugins, topics, topic monitor. Oh, come on. Why? Why? How about we reboot? I want to end on a high note. Let's reboot the Pi. All right. Wait for this thing to come back up. Looking at the blinking lights. All right, maybe it'll let me in now. Not quite yet. Still blinking light. Oh, there we go. Source. Micro-ROS workspace. Source. Local. We got micro-ROS agent. To reboot our Pi again. Just because we don't have a reconnection thing working yet. All right, we got our agent running. Run ROS. We got ROS2 topic list. Why is it not working? We got add a laser scan. See laser scan. There we go. Perfect. Back on a high note. Okay. It is scanning. We can disconnect the debugger. We can move the thing to the middle of the room. And see all the data changing. Yeah, and our boxes. We can see that we are status. Yeah, we see that we're receiving data at about 5 hertz, which is what we expect from a XV11 LiDAR. All right. So changing the STDIO put string thing really changed the game quite a bit. And actually, let's just as a curiosity on the bandwidth thing. So if we do term, if we log into the Pi, and then we do a source, opt ROS Jazzy, do a ROS2 topic list. Do a topic, bandwidth, laser scan. We're looking at, 14 kilobytes per second from messages and such. Just fine. Kilobytes a second. That's definitely a decent amount of bandwidth coming in. So ROS2 topic, echo, pico, firm, ROS2 topic list. ROS2 topic, echo, PiBot, firmware, LiDAR, RPM. That's our RPM on our laser, which is still on which is slower at the moment. But let's just for one. So yeah, that was nice. But let's see. We got Pi, Pico, fast, fast STDI. I think there's just a few defines we can change. There is a TUSB. I know there's some TUSB buffer size. Improve Pico SDK. You might find a configuration option like TUD vendor buff size. Oh, come on. I think it's something like. Oh yeah. Here we go. Target compile definitions. Okay. was this year. Okay. Let's see what happens if we change this to TUD opt high speed. So if we change this to, if we go back to our CMake lists, we configure this as, well, actually, I might have to set this in top level. I don't actually know. Actually, how do we set this officially? Let me just make sure I'm doing this right. Pi pico SDK set. Okay. I wonder if it's just enough to set it on over here. Oh, probably. Oh, it's not happy about me for that one. Okay. Well, all right, instead of defining that, we can do that equals 512. That equals 512. Transmit buff size and TUD CDC EP buff size is 512. Okay, that's probably fine. There we go. All right, let's see if that does anything. I mean, we're already transmitting fast enough, but I am very curious. If that does anything. All right, so we shall Flash project, make lists, laser scan, .8 hertz. All right, so it is clearly still working. Let's go back to our main here. Let's re-enable the motor PWM. There we go. It is operating at 300 RPM as it is supposed to. Alrighty. We'll disconnect the debugger here. I'll put it back in the middle of the floor. There we go. There we go. It's running as we would hope it that it would. All right. And again, we have been doing this. We're doing this with micro-ROS on top of FreeRTOS with some of the other code running from our well, we'll have to publish our IMU type stuff at some point. But anyway, we'll have to write the IMU publisher in the future. But yeah, we are. So today, in the last 5 hours, 20 minutes. All right, so again, I will actually be calling it here. I'm not going to keep tweaking, but yes. So, so today what we managed to do was we looked at micro-ROS for the first time. We got, so we looked at micro-ROS for the first time. We got it compiling for the RP2350, which is in the PyPico 2, and that was really cool because by default, all of the binary blobs are built for the RP2040, which means we had to edit the toolchain files and do a lot of stuff and do the thing. We went through Docker to figure out what was wrong. We ended up resolving that issue about the SDK version causing a compilation failure. Then we got that working. We ran the example on a standalone 2350. We then migrated that to use FreeRTOS again on our 2350, but we didn't know whether that was actually really working because there was only one thread. And so then what we did is we took all of the code that we've been writing for this robot, and we spliced in the micro-ROS support. We put micro-ROS into the existing FreeRTOS thing that we had been building, deleted all the old balancer code that we're not using anymore, because I initially derived this from the code base for the balancer that was based on a PyPico. Because again, it has the same IMU, has the same processor. It was on a W, so it was on a Pico W, so it was still something we wanted to be on the Wi-Fi so we could control it. But now we're working on ROS. So micro-ROS, we even wrote the decoder. Admittedly, I did gloss over how the DMA stuff works, but realistically, this is just all the DMA stuff is to get the data out of the UART fast enough. Then it wakes up a LiDAR task, which processes the LiDAR data, and then it processes that into a micro-ROS laser scan message, and then it publishes it via micro-ROS up to our ROS system. We built the agent on the Pi, so RViz is running on my desktop inside Docker, displaying data sent over the network by the Pi, which is receiving the data from the RP23 from the Pico 2. So we're already demonstrating a multi-node, like multi-computer, network-based, micro-ROS to ROS desktop for visualization. Again, using the LiDAR, we could clearly see that we're getting the data out of the LiDAR. The only thing that's kind of a curiosity now is that we do need to figure out if there's a better way of representing, scans that aren't measuring right. And we need to figure out, why is this 359 points and not 360 points? Clearly, I've messed something up. But other than that, this is really good. We've got a laser scan. So next time, what we'll probably do is we'll start working on what's called a URDF, which is basically, one, you can use them as part of a simulation model for the robot. Two, they define the relationship of various parts in the robot with each other. So probably over the weekend, I might try to make some 3D models of the chassis the chassis components, or the parts that are things that came with the chassis kit. And so that maybe next week we'll start putting together this URDF so we can visualize the robot. We can have all the bits plugged into where they're supposed to related to the other stuff. And then, no, I've got the hiccup, sorry. And then in future streams we'll do the controls. Jesus, the control system. Okay, sorry. All right, so that's what we got done today, which was actually quite a bit. So I'm signing off for the evening. I hope you all had a good time watching. We've definitely been on here for a really long time. But see y'all later. Hopefully see y'all in a stream next week. I'll have to be doing it remote if I manage to get it done, because I'm on a business trip. But again, it'd be really cool to see some of this working. I mean, to get the simulation models working, or the URDF. Either way, I'll make a post about what the next stream will be, when it is, if it is. Yeah, so thanks again for watching. We actually got a fair amount done today. Good night, everyone.